Hello, in this video we're going to put together all of the techniques learned between algebra and calculus to sketch the graph of the function f of x equals x cubed minus 10x squared plus 25x. So the domain, this is a polynomial, so our domain here is going to be all real numbers, so that means we're not going to have any places where our function derivatives or anything like that are undefined, because polynomials are always smooth and continuous. All right, first let's find our x-intercepts. So we'll start with the algebra portion of this. So x-intercepts, remember, are going to be when y is equal to 0. So we'll plug in 0 for our f of x. And we want to find the x values that will solve this equation. Let's factor out, we've got a GCF of x on the left, so if we factor that out, we're left with x squared minus 10x plus 25, and 10x squared minus 10x plus 25 is a perfect square trinomial, and it's going to factor to x minus 5 quantity squared, because the factors of 25 that add to negative 10 are negative 5 and negative 5. So we're going to get x-intercepts at 0 and 5. And you can even go as far as to say the multiplicity of x of that 0 at 5 is 2, so that means that our function is going to bounce off the x-intercept or the x-axis at that point, but we're actually going to be able to pick that up in our calculus as well. All right, our y-intercept is when we plug in 0 for x and we solve for y. And we do see that if we plug in 0 here, we do get 0, which is good, because if you have an x-intercept at 0, you will also have a y-intercept at 0. So that means we're going to have intercepts at the origin and at the point 5, 0. So those are our x-intercepts. And that is pretty much all of what we're going to do as far as the algebra is concerned. So now we're going to look at what we have been doing with increasing and decreasing concave up and concave down. So let's find our first derivative. So the first derivative of our original function here is going to be 3x squared minus 20x plus 25. And now we need to find our critical values. So we need to find where this function is either undefined or equal to 0. And it is never undefined because we have a polynomial. But it is equal to 0. We have 3x squared minus 20x plus 25. This does factor. If you don't recognize those factors, then you can use the quadratic formula to solve this equation. But I'm going to go ahead and use the, it's called the AC grouping method to factor this. So we're looking for factors of 3 times 25, so factors of 75 that add to 20. And those factors are going to be 15 and 5. Both of them are going to be negative because we want a positive 75 and a negative 20. And so I'm going to replace that negative 20x with negative 15x minus 5x. And then factor that by grouping. We have a GCF in our first group of 3x. When we factor that out, we're left with x minus 5. And GCF of the second group, we've got a negative 5. I'm going to go ahead and pull the negative out because I want these two inside the parentheses, those two factors, to be the same. And so we'll get x minus 5 again. Again, these have to be the same. If they're not, then you've either picked the wrong numbers or this will not factor on this method. And so now I'm going to factor out my common factor of x minus 5, and that's going to leave me with 3x minus 5. Set each of those equal to 0. We're going to add 5 to both sides and get 5 for our first one. We're going to add 5 and divide by 3, and so we get 5/3 for our second one. So we have 2 critical values here. And so let's see how that splits this up as far as increasing or decreasing. Make sure that when you put your critical values on the number line, you put them in numerical order. So 5/3 is smaller, so we're going to put it on the left, and then 5 on the right. And we are picking a test point in each of those intervals. I always like to use 0 when I can. 5/3 is just a little bit shy of 2, so I'll go ahead and pick 2 there. But you can pick anything in between those, and then anything bigger than 5, I'll go ahead and pick 6. We are plugging into our first derivative here. So if we plug in plug in 0 into our f prime, we are going to get 25 there. That means that our function is increasing on that interval. And then if we plug in 2, I get -3 plugging into our first derivative. So that means it's decreasing on that interval. And then if we do the same thing and plug in 6, I get 13. So it's back to a positive, so it's increasing. This tells us that we're going to have a minimum value at the point x = 5 because it decreases and then increases. And we already know that y value because we've already found that point. And we will have a maximum value when x is equal to 5/3. And if we plug that back into our original function here, plugging 5/3 into that original function, you get, looks like 500 over 27, which is just shy of 18.5. So 500 over 27. And so for graphing purposes, that means our y value there is going to be a little bit bigger than 18. All right, so there's our increasing, decreasing. It's increasing on the interval from -infinity to 5/3, decreasing from 5/3 to 5, and then back to increasing from 5 to infinity. All right, let's go ahead and find our second derivative. So now we're taking the derivative of this 3x squared minus 20x plus 25. So if we take that derivative, we're going to get 6x minus 20. And 6x minus 20, again, is always defined, so we aren't going to get any points of inflection from where that's undefined. And if we set it equal to 0, 6x minus 20, we're going to add 20 to both sides, divide by 6, and we get 10/3 is equal to x. So we will have a change in our concavity, or at least something happening at x = 10/3. We're going to do the same approach that we did on the last one. We're going to plug in a test point on either side. To the left, I'm going to pick 0. 10/3 is a little bit bigger than 3, so I'm going to go ahead and pick 4 for our right. We're plugging into our second derivative. And so if we plug in 0 there, we are going to get -20. That means our function is concave down. And if we plug 4 into our second derivative, we get 4. So our function is concave up to the right of 10/3. That does give us a point of inflection when x is equal to 10/3. And if we plug that 10/3 back into our original function, that x³ minus 10x squared plus 25x, we can get the y coordinate at that point. And so if we plug in that, I get 250 over 27, which is a little bit bigger than 9. So now we are ready to make a table and figure out what's happening here. So we have stuff that is changing at 5, 5/3, and 10/3 as far as our increasing and decreasing go. So I'm going to go ahead and put those in order. 5/3 is the smallest, 10/3 is in the middle, and then 5 is our biggest number there. And that is going to break our graph up into a total of 4 pieces. To the left, in between 5/3 and 10/3, between 10/3 and 5, and then to the right of 5. So for our increasing, decreasing, we see that it is going to be increasing until we get to 5/3. And then it is going to be decreasing until we get to 5. So both of these are going to be decreasing till we get to 5, and then at 5 it goes to increasing. And for our concavity, to the left of 10/3, it's concave down, so it's going to be concave down on our first two pieces until we get to 10/3. Then it changes to concave up. So if our function is increasing in concave down, that means it's going to look like the left side of a frown. If it is decreasing in concave down, that's going to give us the right side of a frown. And then decreasing in concave up is going to be the left side of a smile. And then increasing in concave up is the right side of a smile. So if we put that together to sketch our graph, not letting me move. All right, so now we want to put everything together, so let's go ahead and plot all of the points that we know. We know we have a x-intercept at the origin and at the point 5, 0. We know we have a minimum at that point 5, 0, a maximum at the point 5/3, 527ths, and a point of inflection at 10/3, 250/27ths. So we're just going to graph each of those points. And so I'm going to go ahead and go up by 10 on my y-axis, because that 527ths is just shy of 20. And looks like all of my y values are positive for all of those points. And then we have our x value needs to go out to 5, so make sure that you plot out to 5. All right, so if we plot, we've got something happening at 0, 0, at 5, 0, at 5/3. 5/3 is a little bit smaller than 2, and then 527ths is 18.5 approximately. And then we have a point of inflection there at 10/3. 10/3 is just a little bit bigger than 3. And 250/27ths is just a little bit bigger than 9. And then now all we need to do is put in our points. And so to the left of 5/3, our graph is going to look like the left side of a frown. So 5/3 is this maximum point here. It's going to go through this x-intercept, and it's going to go through it in a shape that looks like the left side of a frown. And then between 5/3 and 10/3, it's going to look like the right side of a frown, connecting those dots. And then from 10/3 to 5, it's back looking like the left side of a smile. And then once we get past 5, it's going to look like the right side of a smile. And so there is a sketch of our graph. All right, I'll see you guys next time.